Hi everyone, myself Revati, Assistant Professor, Department of Artificial Intelligence and Data Science, Ramco Institute of Technology, Rajapalayam. Today we'll discuss about disk scheduling algorithm. In this, we will see why disk scheduling is important and what are the important terms in disk scheduling, and also what are the different types of disk scheduling involved in operating systems. So, these are all the topics covered by today's lecture. The types of disk scheduling algorithms are first come first serve, that is FCFS. Next one is SSTF, shortest seek time first. Then scan. Next one C scan, look and C look. We will see all those things one by one. Why disk scheduling algorithms are important? Disk scheduling algorithms are otherwise called as IO scheduling. So, which is done by operating system to schedule the IO request arriving from process for the disk data efficiently. Okay, so we need to select the process and the corresponding request will be accessed by the disk controller, and the data will be retrieved from the disk. Okay, so if suppose multiple IO requests may arrive by different process, and only one IO request can be served at a time by the disk controller. So this is the concept. At that time, other IO requests need to wait in the waiting queue and need to be scheduled. Here, for example, two or more requests may be far from each other, so can result in greater disk arm movement. Thus, hard drives are one of the slowest parts of the computer system and need to be accessed in an efficient manner. Important terms. For this disk scheduling algorithms, we need to conclude the seek time, rotational latency, transfer time, and disk access time. Let us see these things one by one. First one is seek time. That is the time taken to locate the disk arm to a specified track where the data is to be read or write. So we have to move the read and write head to the corresponding place where the data is actually stored in the disk. That is called as seek time. The second one is rotational latency. This is nothing but the time taken by the desired sector of disk to rotate into a position. Suppose if the sector is here, the disk should be rotated towards the read and write head. Then only the data will be read or write so that it can access the read and write heads. Then transfer time. Transfer time means time to transfer the data. That is the data transfer from IO device to the computer. This is called as transfer time. And the last one is disk access time. The sum of all these things, that is seek time, rotational latency, and the transfer time. So this is called as disk access time. Next we come to the first come first schedule disk algorithm. So this is the simplest and straightforwarding algorithm, and also is the simplest of all the disk scheduling algorithms. Here the requests are addressed in the order they arrive in the disk queue. That is, the request which come first will serve first. Okay, so let us see one example for this. Suppose the order of queue request is 82, 170, 43, 140, 24, 16, and 190. And the current position of read or write head is 50. Let us take the disk scan from 0 to 199. Okay, so here 200 tracks are there, and the current position of read and write head is at 50. Now, the first request is 82. So, the read and write head is now at 82. So, we need to connect 50 and 82. After that, the request, the data is available in the position 170. Now, the read and write head is moved to 170, and we need to move 82 to 170, and after that 43. Hence, the data should move from 170 to 43. Okay, so this will take some time. For each and every read and write head movement should take some time. See, after that the data is available from the position 140. Okay, now the read and write head should move from 43 to 140. After that 24. 24 is here after 16. 16 is here. Finally, 190 is here. So, in FCFS scheduling algorithm, the read and write head movement is like this. Like the movement is zigzag. For this now, we have to compute the seek time. Here, the total seek time is calculated is as follows. At the position is 82. First, the current position is 50. The data is available at position 82. So, we move from 82 to 50. What is the movement here? 82 to, that is 82 minus 50. That much distance the read and write head move. Next one is 82. The read and write head is moved to 170. Okay. So, the distance is 170 minus 82. So we have to get the largest number first and the smallest number next. Next, the value is 170. The read or write head move to 43. The movement is 170 minus 43. After that, 43 to 140. So the movement is 140 minus 24. Now the read or write head move to 24 to 16. The distance is 24 minus 16. After that, 16 to 190. So the total movement is 642. Total movement is otherwise called as total read or write head. Okay. So it will take the seek time is 642. Coming to the next algorithm, shortest seek time first. I already told is the simply called as SSTF. Here, the requests having shortest seek time are executed first. The seek time of every request is calculated in advance in the queue, which are waiting in the ready queue, and then they are scheduled accordingly. Okay, the seek time of every request is calculated in advance in the queue. So, which are waiting in the ready queue, and then they are scheduled accordingly. The request near the discount will get executed first. This is the importance of shortest seek time first scheduling algorithm. Okay. Also, this algorithm is an advancement of first come first serve. Okay, that is FCFS. Let us take the same example of SSTF. The requests are 82, 170, 43, 140, 24, 16, and 190. So these are the available requests. The current read and write head position is 50. From 50, we need to identify the SSTF, that is shortest seek time first. See, nearby 50, 43, and 52. By comparing 43 is the shortest distance. Okay, the controller will start the 43. So from 43, of course, 24 is the shortest one. So 24 will be selected. After that, 16. From 16, the shortest one is 82. So, the movement is 16 to 82. The head will move and the request is after that the 140. Next, 170. The controller will select the 170. Finally, the 190 will be selected and to be executed. Now, we conclude the seek time 50 minus 43. Okay. Then 43 minus 24, 24 minus 16, 82 minus 16, 140 minus 82, next 170 minus 140 and final 190 minus 170. So, the final seek time is 208. See, while comparing first come first serve algorithm, the shortest seek time first algorithm will give the better result. The next one is scan scheduling algorithm. Scan algorithm are sometimes called as elevator algorithm. So the scan algorithm is very simplest because the disk arm starts at one end of the disk and moves towards the other end of the disk. That is continuously moves after end once it come back to the previous end, so all the services taken forward direction and then only it can be reverse direction. Okay, so this is called as scan. So it can completely scan one direction to another. Here we can take the same example. So the available requests are 82, 170, 43, 140, 24, 16 and 190. The same current position is 50. Okay, so that is the read and write head position is 50. And here the discom should move towards the larger value. That means from 50, it will start the largest value. Okay, so which is the largest value from 50? 82. The head will move from 50 to 82. After that 82, which is next largest to 140. So that it moves to 140, after that 170 and 190 like this. After 190, it will go another end, which is 199. Then only it will be reversed in between the read and write head. Cannot be reversed. Now we have to compute the seek time 199 minus 50 plus 199 minus 16. So the calculated seek time is, that is the total seek time is 332. Okay. The next algorithm is C-scan. C-scan is somewhat is similar to scan algorithm. Also it is called as circular scan. Provides more uniform weight than scan. That is more uniform waiting time compared to scan. The head moves from one end of the disk to the other end requests are serviced. Okay, so when it reaches the other end, however, it immediately returns to the beginning of the disk without servicing any request. Here also we have to take the same request 82, 170, 43, 140, 24, 16 and 190. The current read and write position is 50. The discom move towards the larger value from 50. The move towards one end, that is 199. When returning the disk arm, it will not do anything. It directly come to the another end 0. After that, it moves the disk arm to the increasing order. Let us compute the seek time. So the total seek time is calculated as follows: 199 minus 50 and 199 minus 0, then 43 minus 0, then the total seek time is 391. Okay. So this is nothing but C scan. So the look algorithm. So look is similar to scan, but it accepts that the disk arm goes only to the last request to be serviced. That is the extra delay. So it occurs in the look scheduling algorithm. Thus, it prevents the extra delay. So let us take the same example. The requests are 82, 170, 43, 140, 24, 16, and 190. From 50, the service will move to larger value, which is 42. The read and write head will move up to 190. Okay, so it will not move 199 like scan. The advantage of look is it will reach only the last request. Next it is move to, that is move towards the reverse direction up to 16. Then we have to calculate the total seek time is 190 minus 50 plus 119 minus 16. So the total seek time is 314. The final one is C look algorithm, that is a circular look. It is similar to C scan algorithm. The disk arm only goes to the last request to be serviced. It also prevents the extra delay which occur due to unnecessary from to the end of the disk. Okay. Here also the same request we are taken. Then the read and write head on position is 50. The disk arm move from 50 towards the larger value, that is up to 190. Once it reaches the request at one end, then it travels towards to the another direction. Our other end is we have to call 16. After reach 16, it moves the increasing order. Finally, we have to calculate the total seek time is 190 minus 50, 190 minus 60, 43 minus 60. So the final seek time is 341. Okay. So the diagram is looks is as follows. Okay. So these are the some of the discussed scheduling algorithms discussed in today's lecture. So thank you. Thank you one and all.